Alright, here's our Unit 4 Day 5 video. Please remember that in Unit 4 Day 4, I'll bring that up here for you, we talked about side, 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 and side, angle, side congruence of triangles. We mentioned that that was a shorter way to prove the triangles were congruent rather than having to show that all corresponding parts of the triangles were congruent. Okay, well, we have some other shortcuts we can take in proving that triangles are congruent. Okay, and those are ASA, AAS, and then HL. And this is a unique one we'll talk about at the end of the video. But these first two, the A's and S's, stand for angles and sides. So the first one is called the angle-side-angle congruence theorem. And here's what that looks like. If two angles of one triangle are congruent to two angles of another triangle, and the included sides are congruent, then the triangles are congruent. So in this example, if angle A is congruent to angle D, and angle B is congruent to angle E, and AB is congruent to DE, those are called the included sides. It's the sides shared between the two angles. So we had included angles last lesson. Well, now we have included sides. So if those three things are congruent to these three things, then the triangles are congruent by angle-side angle. Okay, so we're going to do an example proof that uses this information. Right, for example 1, here's what you need to copy down. The given statement is that angle BAC is congruent to angle DEC. C is the midpoint of segment AE. And we want to prove that triangle ABC is congruent to triangle EDC. And again, we're going to use angle-side angle on this proof. And I want you to draw this picture, okay? And you'll notice that I started by segments AB and DE on notebook paper lines. Okay, so you can tell they're going to be parallel. That's going to help you draw this figure. But try and draw the figure like that. And label the points A, B, C, D, and E like I have. So make sure you have that copied down correctly. And then we'll start with our statements and reasons. This is going to take us 5 steps. All right? And then we'll just start to go through our proof. If you need more time to copy any of that down, go ahead and pause the video. But otherwise, you should be able to follow along here. Okay? Once again, we want to use these steps separately in a proof. We want to separate some of that given information out then. Okay? So we start with an angle congruent to another angle. Angle BAC is congruent to angle DEC. So I want to mark that in my diagram. I'm going to mark the givens as I go. That angle is congruent to that angle. It's that given statement. Okay, I'm going to go ahead and write that first in the proof. Okay? So there's a pair of congruent angles. Let me tell you that C is the midpoint of AE. Now that statement leads me to a secondary statement. If you'll remember in class, we started working on these proofs by kind of making notes as we went along. If C is the midpoint of AE, that is going to tell us that these segments are congruent by the meaning or definition of the word midpoint. So after I state that in the proof, the next statement will be that AC is congruent to EC. Okay? And so that would be by definition of midpoint. Okay, so that's going to be a statement in a proof after I make that statement. So let's go ahead and try that. Let's now state that C is the midpoint of segment AE because it's given. Then I can make this claim. Now let me backtrack just a minute. On the first statement, that's a pair of congruent angles. So if you're keeping track, we've stated a pair of congruent angles. This leads me to a pair of congruent sides. segment AC is congruent to segment EC. The reason for that is definition of midpoint. And so there's a pair of congruent sides, and these are the included sides between angle A and E from the given. But also, if you look at the other side at the other end of this segment, or sorry, other angle at the other end of this segment, that's the angle here formed at C. That angle has to be congruent to this other angle because they're vertical angles. So that's my other pair of congruent angles. The angle ACB is congruent to angle ECD because they're vertical angles. So that's the vertical angles theorem. Okay? And that's the other pair of congruent angles. I've shown two pairs of congruent angles, and the included sides are congruent. So that's angle, side, angle. So triangle ABC is congruent to triangle EDC by angle, side, angle. We finish our proof. All right, and that leads us to another congruence theorem called angle-angle side. Now, the only difference between these two is that in the first theorem today, the sides that were congruent needed to be the included sides. The included sides needed to be congruent. But because of the way triangles work, if these two angles are congruent to these two, the third pair of angles have to be congruent. There's actually something called the third angles theorem. That states if two angles of one triangle are congruent to two angles of another, then the third pair of angles have to be congruent because of the third angles theorem. Okay? And so that allows me to write this congruence theorem for triangles. If two angles and a non-included side of a triangle are congruent to two angles and a non-included side, of another triangle, then the triangles are congruent. And I'll show you what that looks like. Okay, if angle A is congruent to angle D, and angle B is congruent to angle E, and then these non-included sides, BC and EF, the markings are not between the two congruent angles, but they're on another side. If those are congruent sides, then the triangles are congruent by angle-angle side. Okay? And this non-included basically just means any side that is opposite one of the two angles. Okay? So you can even write that down. Non-included means a side opposite one of the angles that are marked congruent. Okay, so let's try and do a proof using this theorem. Okay, if you need to take a moment to pause the video to copy this down, go right ahead. Make sure you do that before you try and follow along with the video, especially the given statements and what you're trying to prove, and the diagram. Make sure you get this drawn correctly, otherwise your proof won't make a lot of sense when you look back at your notes. All right, hopefully you've had enough time to copy that down. We want to take a look here at the given information and see if we can use angle angle side to prove that these two triangles are congruent. We are told that this segment bisects the angle WYX, and that means it divides this angle into two congruent parts. Remember, an angle bisector, or when it says something bisects an angle, that's telling you that you get two congruent angles. So that is going to be one of the pairs of congruent angles. And we're told that angle W is congruent to angle X. That's another pair of congruent angles. And then we can figure out a pair of congruent sides from the given information also. Okay, so we're going to start by marking the given information. Now, this given statement does not directly tell me that angles are congruent, but it leads me to the next statement that these angles are congruent. That angle WYZ is congruent to angle XYZ because of the definition of bisect. Okay, so that's going to be the secondary statement after the first one. But this is a direct congruence of angles statement. So angle W and angle X are congruent. And then I need a pair of congruent sides. Now if I want to use angle side, I do not want to try and say that WY is congruent to XY, but I want another pair of congruent sides. Well, anytime two triangles share a side, we can always use the reflexive property to state that those are congruent. That would be a secondary congruent statement also. And so let's try and go back and fill in our proof then. The first statement is that segment YZ bisects angle WYX, which is given. And remember we said that that tells us these two angles are congruent. So the next statement is that angle WYZ is congruent to angle XYZ because of the definition of the word bisect, or definition of angle bisector. So there's a pair of congruent angles. We were also given that angle W is congruent to angle X. That's another pair of congruent angles. And then number 4, we can state that YZ is congruent to YZ. Both triangles have that as a side, so by the reflexive property, we can state YZ is congruent to itself. That's the pair of congruent sides, and those are non-included sides between these two. This YZ segment is opposite angle W and opposite angle X. So we've shown angle side, which is enough to say the triangle WYZ is congruent to triangle XYZ by angle, side, which is what we were trying to prove. All right, and finally we have one other congruence theorem, and that's called the hypotenuse leg congruence theorem, HL, hypotenuse leg. And this only works for right triangles. It does not work in all other triangles, but in right triangles where we have a hypotenuse and the other two sides are called legs, we can use hypotenuse leg. It has to be right triangles. It will not work any other time. In any other triangle, there is no such thing as a hypotenuse. Hypotenuses, or hypoteni, only exist in right triangles. Okay. If the hypotenuse and leg of one right triangle are congruent to the hypotenuse and leg of another right triangle, then the triangles are congruent. So in triangle ABC, we have a right angle at A, and in triangle DEF, we have a right angle at D, making these right triangles. So if BC, that's the hypotenuse, is congruent to EF, and AB is congruent to DE, those are both legs, then the triangles are congruent by HL. Remember that the hypotenuse is the side that is opposite the right angle, and then the other two sides are legs. Okay, we're going to do an example in class. Okay, video won't have time for it this time, but we will do an example like this in class.